Bonjour tout le monde, je m'appelle MK, and let's talk about today's LeetCode daily challenge. I'm going to say hi in a new language every time. I'm going to try to do that, just because I like languages. Okay, out of boundary paths. This is an interesting problem. I like it. So we are given an m by n grid with a ball. So there's a ball on this grid. The ball is initially at position start row and start column. So we are given the initial position. You are allowed to move the ball into one of four adjacent cells. So up, down, left, right, the usual. You can apply at most max move, number of moves to the ball. Okay, so what should we do with max moves? Let's read. Given the 5 integers, so the dimensions, m by n, the max move, and the start row, start column, we should return the number of paths to move the ball out of grid boundary. So the number of different paths to move the ball out of the grid boundary. And once the ball is out of the grid boundary, you cannot come back. So that's it. So you don't have to use all of the max moves. And since the answer is going to be very large, you should return the answer modulo a very big number, a very big prime number. This is a prime number. Let's look at the example. So this is a 2x2 matrix, 2x2 grid, yeah. And max moves 2, and the start row and column is 0 and 0. So if we make one move, we can just go outside of the grid. So in 2 different ways, we can go outside of the grid with one move. With 2 moves, we can do 4 different ways. So down, left, down, down, right, up, right, right. And that's it. We cannot, 1 or 2 moves, so max moves. So this is 6 different ways. Another one is m is 1, n is 3, and max move is 3. So one way, if we want to use only one move, is go up or down. 2 move is left up, left left, left down, or right up, right right, right down. With 3 moves, we can go left right up, or left right down, or right left up, or right left down. So in total, it's going to be 12 of them. So 2 here, 6 here, it's going to be 8, and 2 here, and 2 here. It's going to be 12. The dimensions are not big, so 50 by 50, so we may be able to do something here. If you have solved a few dynamic programming problem, this problem is shouting to be solved by dynamic programming. Why? First of all, it's a counting problem. So counting problems, most of them are solved with a dynamic programming approach. The number of different ways is very big, so you cannot count every single one of them. So every path is going to be depending on other smaller paths recursively. So that is another hint that this could be solved by dynamic programming. Another one is that you can actually have a recursive formula. Let me show you how. So let's say you are here and the ball is here. The ball is here, and you have remaining number of moves to max number of moves to make. Okay, so the answer of f max number of moves at this cell, so I'm gonna say R and C and max move, f of R, C, and max move, that is what the problem is looking for. So the number of ways to move the ball outside of boundary if we are standing on R and C and we have max number of moves to make. This is what the problem is asking us. So this is depending on 4 different answers. So we can either, for the first move, we can either go up. If we go up, it's going to be f of R minus 1 and C. And we did a move, so it's going to be max move minus 1. Or we are going to go right. So this is going to be f of R and C plus 1 and max move minus 1. You see what's happening? So we are moving into one direction and we are decreasing the max move by 1 because we just made a move. This is the move. This is the move. Okay, and so on. So this is going to be f of R plus 1, C, and max move minus 1. And this is going to be f of R and C minus 1 and max move minus 1. So great, we found the recursive formula. This is very important when you want to solve a problem with dynamic programming approach. The next step is to find the base case. So what is the base case? Because when you are having a recursive formula, if you don't have a base case, it's going to keep going back, like keep decreasing until negative infinity. But that is not what we are looking for. We should stop at some point. This max move is going to be decreased by 1 at every move. It's going to be decreased by 1 at every move. So what we need is actually the base case is also defined for us here. The base case is this: the ball out of the grid boundary. So when the ball is out of the grid boundary, we return 1, because that's one way of doing that. Like, this is the grid and this is the grid boundary. So let's say we are here. So let's say we have gone from this cell to this cell, okay? And it's going to be like f of -1, because the row is -1, and some column, doesn't matter what is that, some column, and some max number of moves. It doesn't matter, again, max move. We know it's greater than or equal to 0. Max move at this point is greater than or equal to 0. That means when we were here, we had at least 1 move, so we could go up. So this is at least 0. So this is valid. So this -1 is out of bound. So let's read this and see what does this mean. This means in how many ways we can move the ball to the outside of the grid if we have max number of moves, and we are already outside of the grid. We are already outside of the grid. That means the answer is 1. In one way, do nothing. Do nothing. That's it. That's why we are returning 1. Okay. So we have the recursive formula. So we have the recursive formula. We have the base case. That's it. We have the dynamic programming approach. And also you should be careful about overlapping subproblems. Can you think why this recursive formula has overlapping subproblems? Think about it and ask questions in the comment if there is a question. So let's go and see how we can write the code for this. So we have m and n. So I'm going to define int m and int n as members of the class, not to pass them every time. And I define a function int f, int row, int call, and int max move. Okay. And I need some const int mod for the module 0. Okay. Here is 1,000,000,007 mod. And then here we have int. So the base case was this: if row is less than 0, or call is less than 0, or row is equal to this m, or row is equal, call is equal to this n. So that means this is out of bound. We just return 1. Okay. If the other base case is that we have ran out of max move and we have not still got out of the grid. So here it means if we are here at some point in our code, it means we are not out of the grid. Okay. And so if max move is 0, that means we cannot make any more moves. So return 0. There's no way to go outside of the grid if you don't have any moves left. So return 0. Otherwise, we define int result to be 0, and result is going to be the sum of these 4 numbers. Okay, so f of row -1, call, max move -1, and result plus and mod. And we do this 4 times. So row +1 and max move, row and call -1 and call +1. That's it. And then we return result. Here we just return first we should set m and n. So this m equals m, this n equals n. Return f of start row, start call, and max move. So this is the recursive solution. We have not memoized it yet. Let's see if this works. Yes, it works. Let's just have another test that's going to give us time limit. So let's say 10 by 12. Max number of moves is going to be 20. And the start row and start column, let's say 0 and 0. So this is going to give us time limit, hopefully. Yeah, because we are not memoizing answers to the subproblems. In order to do that, we define a table. So it's going to be vector of vector. We need a 3-dimensional vector because of the state: row, column, max move. So vector of int dp. And then here we are going to resize it. And we are going to say dp.resize m of them, and vector of int, each one should be n of them, and we need vector of max move plus 1, sorry, vector of int max move plus 1 and -1. So this is how we initialize a 3-dimensional vector. So this means m 2-dimensional vectors, and then inside this we have n 1-dimensional vector, and then inside this we have max move plus 1 numbers. So this is how you can think of it. And here we say if dp of row and call and max move is not -1, that means this number has already been calculated. Return dp of row, call and max move. Otherwise, here before returning, save it. So dp of row, call and max move should be result. So let's run this now and see if this works. Yeah, and the answer is going to be very big. Let's also try the biggest, like the maximum dimension. So let's go for 50, 50, and 50. Okay, that is 50, 50, and 50. Yeah, and the starting row, let's say 5 and 5. Okay, this seems to be working. Let's submit. Okay. Let me know if you have any questions in the comment. Please like and follow and subscribe if you enjoy my explanations, and please introduce me to your friends if you like the video. Thank you.